Computer System Servicing NC2 Structured Cabling System. Learning Competencies. At the end of this module, the learners will be able to describe the role of different LAN cable in computer network according to its type. Explain and enumerate the different types of LAN cable and its use. List the standardization organization in computer networking and structured cabling system. And list the evolution and characteristic of computer cabling standardization. Terminologies: TC or thin copper, AL aluminum, ANSI American National Standard Institute, TIA Telecommunication Industry Association, EIA Electronic Industry Association, ISO International Organization for Standardization. Network topology, infrastructure of computer network. Ethernet cable, cable used to connect your computer to the network. ACR, attenuation to crosstalk ration. BER, bit error rate. FEXT, far end crosstalk. NEXT, near end crosstalk. STP, shielded twisted pair. UTP, unshielded twisted pair. What is network cabling? Cable is the medium through which information usually moves from one network device to another. There are several types of cable which are commonly used with LANs. In some cases, a network will utilize only one type of cable. Other networks will use a variety of cable types. The type of cable chosen for a network is related to the network's topology, protocol, and size. Understanding the characteristics of different types of cable and how they relate to other aspects of a network is necessary for the development of a successful network. LAN cable types: coaxial, twisted pair, and fiber optic. Coaxial cable. Coaxial cable is commonly used by cable operators, telephone companies, and internet providers around the world to convey data, video, and voice communications to customers. It has also been used extensively within homes. 1. Center conductor. 2. Center conductor bond. 3. Dielectric. 4. First outer conductor. 5. Second outer conductor. 6. Third outer conductor. 7. Fourth outer conductor. 8. Corrosion resistant protectant. 9. Jacket. And 10. Integral messenger. Coaxial cable is a type of cable that has an inner conductor surrounded by an insulating layer, surrounded by a conductive shielding. Many also have an insulating outer jacket. The diagram below illustrates the construction of a typical cable. Electrical signal flows through. The most common type of connector used with coaxial cables is the Biennial-Conzelmann or the BNC connector. To help avoid problems with your network, always use the BNC connectors that crimp rather screw onto the cable. Second, twisted pair. Twisted pair cabling comes in two varieties, shielded and unshielded. Unshielded twisted pair or UTP is the most popular and is generally the best option for school networks. These are the parts of twisted pair: PVC jacket, AL or PS tape shield, the solid bare copper conductor, foamed PE insulation, and solid thin copper drain wire. The quality of UTP may vary from telephone-grade wire to extremely high-speed cable. The cable has 4 pairs of wires inside the jacket. Each pair is twisted with a different number of twists per inch to help eliminate interference from adjacent pairs and other electrical devices. The tighter the twisting, the higher the supported transmission rate and the greater the cost per foot. The EIA or TIA, Electronic Industry Association or Telecommunication Industry Association, has established standards of UTP and rated 8 categories of wire as shown in the next slide. UTP category 1. Maximum length none, maximum data rate up to 1 Mbps and intended use voice only. 2. Up to 4 Mbps, 4 Mbps token ring. 3. 100 meter, up to 16 Mbps. 10 base T Ethernet. 4. 100 meter, up to 20 Mbps. 16 Mbps token ring. 4. 100 meter, up to 20 Mbps, 16 Mbps token ring. 5. 100 meter, up to 100 Mbps or 2 pair. 100 base T Ethernet. Next, 500 meter up to 1000 Mbps or 4 pair, Gigabit Ethernet. 5E 100 meter up to 1000 Mbps 2 pair, Gigabit Ethernet. 6. 100 meter up to 1000 Mbps, Gigabit Ethernet or 10G Ethernet 55 meters. 7. 100 meter up to 10,000 Mbps, Gigabit Ethernet, 10G Ethernet 100 meters. And 8. 30 meter up to 25,000 Mbps to 40,000 Mbps, 25G base T or 40G base T. Researcher Mr. Bronyoso. Cable type and its specification. Specification 10 base T, cable type UTP. 10 base 2, thin coaxial. 10 base 5, thick coaxial. 100 base T, UTP. 100 base FX, fiber optic. 100 base BX, single mode fiber. 100 base SX, multi-mode fiber. 1000 base T, UTP. 1000 base FX, fiber optic. 1000 base BX, single mode fiber, and 1000 base SX, multi-mode fiber. Category cable shielding. The acronym used to describe the cable shielding have changed over the last several years in order to avoid confusion of the different types of shielding found on category cables today. The mechanical construction of the category cable shielding is identified by specific abbreviations. These abbreviations or acronyms were established by the ISO IEC 11801 standard and adopted by TIA or EIA. The standard abbreviations are as follows: TP, twisted pair; U, unshielded; F, foil shield; and S, braided shield. Example: FUTP, F, describes the overall shielding type. U describes the shielding of the pairs. TP describes the twisted pairs. The code before the slash describes the overall shielding. The second letter after the slash describes the shielding of the individual pairs. Acronym UTP or U/UTP. Pair shielding, none. Description: unshielded twisted pair. Cable shielding, none. F/UTP, none. Overall foil shield, AL foil. U/FTP, AL foil. Each pair shielded, none. S/FTP, AL foil. Each pair shielded plus overall braid shield, TC braid. SF/UTP, none. Overall foil shield plus overall braid shield, AL foil plus PC braid, F/FPP AL foil, overall foil shield plus H pair shield AL foil. Third, fiber optic cable. Fiber optic cabling consists of a center glass core surrounded by several layers of protective materials. It transmits light rather than electronic signals, eliminating the problem of electrical interference. This makes it ideal for certain environments that contain a large amount of electrical interference. It has also made it the standard for connecting networks between buildings due to its immunity to the effects of moisture and lightning. The parts of fiber optic cable: self-support member, outer sheath, fiber, loose tube, water blocking system, and corrugated steel tape. The number of mobile internet users and the proliferation of connected devices have led to the exponential growth in global internet traffic. This traffic will make more network providers to upgrade their networks and introduce more optical assemblies like fiber optic cables, fiber optic connector, and fiber optic transceiver, and etc. Fiber optic connector types are as various as the applications for which they were developed. Different connector types have different characteristics, different advantages and disadvantages, and different performance parameters. But all connectors have the same three basic components: the ferrule, connector body, cable, and coupling device. Ferrule. The ferrule acts as a fiber alignment mechanism and holds the glass fiber. It has a hollowed-out center that forms a tight grip on the fiber. Ferrules are typically made of metal, ceramic, or quality plastic. Connector body, also known as the connector housing. The body holds the ferrule and attaches to the jacket, and it strengthens members of the fiber cable itself. It is usually constructed of metal or plastic and includes one or more assembled pieces which hold the fiber in place. The coupling device. Coupling device is a part of the connector body that keeps the connector in place when attached to another device, like as bulkhead coupler and optical transceiver. Fiber optic connector. The SC, ST, FC, ESMA, LC, E2000, MU, DIN, MTRJ, MPO, D4, and Biconic. Cabling standards. Standard Organization: IEA TIA USA, Electrical Telecommunication Industries Association, CEN ELC, European Committee for Electrotechnical Standardization, the ANSI, American National Standard Institute, IEEE, Institute of Electrical and Electronic Engineer, ISO IEC, International Organization for Standardization, International Electrotechnical Commission. Standard History. ANSI EIA TIA 568, published in 1991. The first commercial building telecommunications wiring standard. The original document, together with TSB 36 and TSB 40, specified the basic transmission requirements of Category 3, 4, and 5. INSI EIA TIA 568A, published in 1995. Recognized cables for horizontal cabling. 4 pair 1000 ohms UTP cables, including SUTP. 2 pair 150 ohms STP cables, IBM Type 1A. Two fiber 62.5, 125, and 5125 fiber optic cable. ANSI TIA EIA 568B.1 General Infrastructure Requirements Copper and Fiber. ANSI TIA EIA 568B.2 Copper Requirements Category 3, Category 5, and Category 5E. And ANSI TIA EIA 568B.3 Fiber Requirements. B2.1 Category 6 Specifications. B2.2 Balanced Twisted Pair Cabling Components. B2.3 IL and RL Pass-Fail Determination. B2.4 Solderless Connection Reliability Requirements for Copper Connecting Hardware. B2.5 Corrections to TIA EIA 568B.2. B2.6 Cat6 Related Components Test Procedures. B2.7 Reliability Specification Requirements for Copper Connecting Hardware. B2.8 Additional Components Requirement for DTE Power. B2.9 Additional Cat6 Balance Requirements and Measurement Procedures. B2.10 Augmented Cat6 Cabling 10G. B2.11 Increased UTP and STTP cable diameter. B3.1 Laser Optimized OM3 MMT Gigabit. TSB 140 Additional Guidelines for Field Testing Length, Loss, and Polarity of Optical Fiber Cabling Systems. EN 501731 General Requirements. EN 51732 Office or Commercial Premises. EN 51733 Industrial Premises. EN 51734 Residential Premises, and EN 51735 Data Centers. Commercial Building Telecommunications Cabling Standard. Link. The transmission between any two interfaces of generic cabling without equipment and work area cables, or where an optional transition connection is allowed. Maximum link length is 90 meters. Channel. The end-to-end transmission path connecting any two pieces of application-specific equipment with equipment and work area cables. Maximum channel length is 100 meters. This ends the lesson. Resources and acknowledgement: ppc-online.com, fcit.usf.edu, fs.com Fiber Optic Connector Tutorial Aid 341.html. Computer System Servicing NC2 Structured Cabling System.